Okay, my name is Elias. For today's lesson, I will show you a simplest method or steps that you can use to prove a product rule from differentiation from calculus. Um, we know that um, from differentiation, we know that a product rule dx of function of x f of x dot g of x here equals to f of x g prime of x then plus g of x and f prime of x. So as we see here, dx or derivative of f of x times g of x equals to f of x times derivative of g of x plus g of x times derivative of f of x. From here now we can prove how to arrive here, how one can arrive up to here f of x g then times g prime over of x. From here I'm gonna let to prove this I'm gonna let capital F of x equals to small f of x dot g of x. This is the product of two linear function, f of x and g of x, f of x and g of x. So I want to prove this. So from differentiation rule, we say that d of x of capital F of x, this one equals to limit from first principle as h approaches to 0, f x plus h bracket here minus capital F of x over h. But remember that we have let this one capital F of x equals to small f of x times g of x. So we substitute these values into our capital F of x here. So it will be equals limit as h approaches to 0 here, then capital F we substitute it by small f plus h here, then g of x plus h minus this one f of x, it's f of x g of x, all of this over h here now. Okay, from here now what you're gonna do here is to add subtract and add f of x plus h g of x into numerator of our formula here. Remember that when we add this and minus, so it will be 0, so it will never disturb our formula here, never change our formula here. So it will be equal limit as h approaches to 0 here equals to f, here will be f of x plus h, g of x plus h, g of x plus h, then minus this one, f of x plus h, g of x, then plus, as we said you add here, plus this one, f of x plus h, bracket g of x, then but we have minus here, so we minus f of x, g of x. All this we divide by h here. From here now we can factor out this one, so it will be limit as h approaches to 0, factor of this one, f of x plus h, bracket here will mean g of x plus h, minus this g of x, then you have plus here, plus factor out g here, you can factor out here g of x, so we have g of x, bracket f of x plus h minus f of x, all of this over h, all this over h. So as you see here, as you can see here, as we apply as we apply limit rule here, as h approaches to 0, here it will remain f of x. As h approaches to 0, all of this from here, this one, all of this, it will be it will be g prime, it will be g prime of x, it will be g prime of x. As you see our formula here, as you see this formula here, we said that d of x of f of x equals to limit as h approaches to 0, capital F x plus h minus capital F of x over h. This formula is like this one, so this will be g prime of x, and this will remain g of x, and this will be f prime of x. So it will be like this, f of x dot, this becomes g prime of x, then plus this one will be g of x, and this dot, so we'll have dot, this is equal to f prime of x. This is our formula, which is equal like this, is equal to this one here, now end of proof. This is our end of proof. This is end of proof. As you see here, our formula here equals to f of x dot prime g of x, g prime of x, and then plus g of x times f prime of x. And now this end of proof. This is how you can prove a product rule from differentiation in calculus. Thank you for comment. Or any question, please you can add it, or you can ask it in the comment section. Thank you.